Hey guys, we're going to do homework 10.1. Okay, so we took some notes on 10.1. And again, the theme is a fraction or a portion of a circle. Our arc length is a fraction, not the whole circumference, but just part of it. And we learned how to do that in radians and in degrees. Not the whole area of the circle, but a part of it. And then this other idea of an area of a segment of a circle. So that's not the pizza slice and not this triangle part, but this part left over. So those were the three things in our lesson. So our assignment starts here. I think most classes I said I'd finish example 5 and then I'd work through these homework problems that's on Canvas. So let's do it. It says, example 5, what's the area of the segment? So we said the area of the segment from our notes would be this blue area, subtracting that triangle. Okay. So it looks like, using our formula, right, the area of the blue part would be our central angle, right, in over 360 times the area of a circle, which would be pi r squared. And that would be our blue part. So that would be 90 over 360 times pi times 10 times 10. So let's see, we have 90 times 100, so that'd be 9,000 over 360 times pi. Okay, that's our blue part. Now we could turn that into a decimal. They don't really ask us to. The other thing is, if I walk back my steps, I know that this is actually a quarter of my circle. So this ratio, 90 divided by 360 is 0.25 or 1/4. And that's 100. So I could also think of this as 100 over 4 times pi. But you're like, wait a minute, 100 divided by 4, that's 25 pi. So that's our blue area, 25 pi. Now let's look at the red area. Well, the area of our triangle, the area of a triangle is base times altitude. So the base here would also be 10. The altitude would be 10. So 10 times 10 is 100. But the area of a triangle is base times altitude divided by 2. So I got to divide that in 2, so I get 50. So my answer is the area of this green part, my segment, would be the area of the triangle, take away the blue part, take away the triangle. Now, if you wanted to make this a decimal, you could. So let's go ahead and turn this into a decimal. Using our calculator, 25 times pi, or 3.14, be 78.5, take away 50, is 28.5. Final answer. All right, now let's do B. Now this one's a little bit more complicated. It's not just a quarter of my circle. So if I look at the blue part, that's 144 over 360 times pi times 5 times 5, pi r squared. 144 divided by 360 is a decimal, 0.4. 5 times 5 is 25. So 25 times 0.4 is 10. Okay, so I get 10 pi, or I could turn that into a decimal if I need to, but I'm not going to do that yet. Okay, now let's look at our triangle here. What is the area of our triangle? Well, again, the area of a triangle is the base, whatever that is, times our altitude divided by 2. So you're like, I really don't know the base, and I don't know the altitude. The only thing I know is that's 5 and that's 5. Those were my radii. So, I also know that this big angle is 144. So if I cut that angle in half, 144 divided by 2, what do I get? 144 divided by 2, I get 72. Okay, so that's 72 degrees. So I think I'm going to have to use trig here. I don't know that, so I'll make that part I don't know. And I can say that the cosine of 72 degrees is x over 5, and that would give me x, or my altitude. So x is equal to 5 times the cosine of 72. So 72 cosine times 5. I get 1.545. Okay. Now I need this base. So we're like, okay, well, I can figure out half of that. I can figure out this part. That would be the sine of 72 is, I'll call that y. Y over 5. So y is equal to 5 times the sine of 72. Let's find out what that is. So the sine of 72 times 5. So we get 4.755. But we need to double that. So 4 times 2. Okay. So my base looks to be 9.511, and my altitude is this 1.545. Okay, so the area of my triangle is base 9.511 times altitude 1.545 divided by 2. Okay, so the area of a triangle, I get 7.347. And what was the area of my blue part? 10 pi. So my answer would be the area of my segment of a circle would be my 10 pi, take away 7.347. So that would be 31.4, take away 7.347. You can see why I didn't do this one in class. I'm like, oh, this would have taken forever. Okay, so this is what I got for my final answer. I'll just round to the nearest tenth. So that's the area of my segment of my circle. Nice. Okay, so let's work through these problems. 11, 14, 17. 11, 14, 17. 19 through 22, 25, 26. 19 through 22, 25, 26. And then 30, 31. Beautiful. Okay. So our questions start here at 11. It says, Steve is asked to compute the area of the shaded region. What is his error? Okay, so we know to find the segment of the circle, he first needs to find this, which that looks about right? That's our angle, a quarter, times, oops, he used the formula for the circumference, and we need the area. Right, so this should be pi radius squared. So this should be pi times 3 times 3. Then he subtracted the area of our triangle. So what's the area of the triangle? 1/2 base times height. Okay, so that part looks good. So what did he do wrong? He used the wrong formula. Okay. He used the formula for circumference instead of the formula for area. Okay, question number 14. Explain why the length of an arc with an arc measure A is proportional to the radius of a circle. Okay, so we'll make a circle here. Why is the length of an arc? So I think if we could do this proportionally, so we'll say this. Why is the length of an arc? So let's think this would be an arc. And let's think about this being an arc. Explain why the length of an arc, so that's what we colored in red, with an arc measure of A. And so we'll call this the arc measure of A, is proportional to the radius of the circle. So this is our radius R. And so I made a different picture. So why would this be proportional? Okay, so I guess I should make one that's bigger. So let's say we make a circle that's double R. So this looks like 2R. And we'll make a circle that's about the same. It looks a little squishier. So this is 2R. Notice there is a proportion here because this got a lot longer. So the larger proportionality works, the larger the radius, the longer the arc measure. Okay, that's nice. Okay, what do we got here? It says, what's the measure of BC? Find each arc measure. So BC, they put a tick mark here, and they said this one is 50 degrees. So if this one's 50 degrees, then this one would have to be 50 degrees. What about 19? What's the measure of CFE? So C, go through F to get to E. Stop at E. So what do we have here? Well, let's see. Those are both 50. This one's 100, right? These two are equal, and this one's 90. So I have to add them all up. I'm going to just number them here. So if this is angle 1, 2, 3, 4, 5, 6, all these angles have to add up to 360. All right. Okay, so that would be 50. The second one's 50. The third one we don't know, so we'll call that X. Not sure. The fourth one we know is 100. The fifth one we don't know, but it's also X because it's one arc mark. And then that one's 90. But all these have to add up to 360. Okay, so that's 100 and that's 100. And that's 90. So those all add up to 290 plus 2X. All right, so almost there. We got X is equal to 35. So I'm just going to start over. This would be 35 and 35. And we could add all those up just to double check our work. I feel pretty good about this. Okay, so the red one would be the 50 plus the 50 plus the 35 plus another 100. So that's 235. Question 20 and 21, each arc length in terms of pi. Okay, so what is the length of it? So we don't want the measure in degrees. It looks like we actually want the length. So this is in relation to that radius. Okay, so the length of JK is not the whole circumference, but part of it. So we have 110 over 360. That's the portion of the circumference that we want. So that's 110 over 360 times 2 pi r, and our radius is 8. And they want it in terms of pi. Okay, so we have a pi, and 2 times 8 is 16. And so we have a big, ugly formula, and so they want us, let's just multiply and divide and see if we get a whole number. So I do 110 times 16, enter, divide by 360, enter, I get a decimal. 4.8 repeating pi, but that's not what they mean in terms of pi. So I'm gonna have to reduce this fraction. That probably doesn't make anybody happy, but. So I can divide both by 10, that's fine. These are both even, so I could do 11 and 16 divide by 2, I get 8. And this divide by 2, I get 18. And those are both even. So you still have pi. Okay, so I'm just going to keep dividing by 2. So I get 11 times 4 divided by 9. Okay, it looks like I'm pretty much done here. So I get 44 pi over 9. Now, just to double check, 44 divided by 9 is, those are the same. So that's my final answer, 44 pi over 9. 21, what is the length of x, y? I'm going to go through y and get to z. Well, it looks like its measure of that angle is 5 pi over 4. So 5 pi over 4. And our formula says we can find our arc length by merely taking our angle, which is what we have there, and multiplying it by our radius, which we have that 3. So our arc length is multiplying these together. So I get 15 pi over 4. Notice radians makes all this work in here. I just went straight there. So it is easier. It just feels more complicated until we get used to radians. All right, now instead of portions of the circumference, let's do portions of our area. So it says round to the nearest tenth. So we have 52 over 360 times the area pi radius squared. So pi times 12 times 12. And I'm just going to turn this into a decimal. So I can just multiply all this together and then divide. So I got 52 divide by 360, enter, times pi, enter, times 12 equals, times 12 equals 65.3. Now I would like to just double check to see if I did that. So it's definitely not the whole circle. The whole circle would be pi r squared, or pi times 12 times 12. So that'd be 144 times pi is 452. Yeah, so that makes sense. This is just a portion of that. 25, it says find the area of each segment, round to the nearest tenth. Okay, so I've got my blue area first. It's my area of a sector. That's 78 over 360 times pi radius squared. So 78 divided by 360 times pi times 5 times 5. And we're rounded to the nearest tenth, so I'm just going to turn this into a decimal. 78 divided by 360 equals, times pi equals, times 5 equals, times 5 equals. I get 17.017. All right, now to get to the green part, right, I want to know the area of that. I have to cut off this red triangle. So, and I'm going to flip that on its base. So this is 5 by 5, and the angle at the top here is 78 degrees. Notice I kind of rotated that around there. So I'm going to cut that angle in half, divide by 2. I get 39. Boo! So I'm going to drop an altitude. This is 39 degrees. And I can find the altitude, and I can find the base. And that's how I'm going to find the area of this triangle. Okay, so the cosine of 39 is x over 5. And so x would be 5 times the cosine of 39. All right, so my altitude is 3.886. And let's solve for y. The sine of 39 would be y over 5. So y would be 5 times the sine of 39. 39 sine times 5. 3.1466. Wow. Okay, so to find the area of this triangle, the area of that triangle would be base times altitude divided by 2. So the base here is 2y, so we got to double that. I'm going to multiply that on my calculator. So I get 6.293 for my base. My altitude we got was 3.886, and then we're going to divide by 2 times 3.886, enter, divide by 2, enter. So the area of my triangle is 12.228. Okay, so to find the area of my green part, I'm going to say it's the blue part. Take away my triangle. It's not leaving me a whole lot left. Final answer, round to the nearest 10th, 4.8. Cool. All right, 26 says, the length of ABC, so A through B, got to go through B, get to C, is 110 feet. So let's figure out what that is in an angle. We know that all the way around is 360. So ABC should equal 360. Take away the 54, right? So that's 306 degrees. What is the radius? Okay, so the arc length, though, our arc length is equal to 306 divided by 360 times the circumference, 2 pi r, right? But they've told us that arc length is 110. So they're kind of giving us this backwards. So I'm just going to recopy the problem down. Notice I need to solve for solve for r, excuse me. So I call this a Lynch swap. I'm going to move this one up here. So, right? I'm going to this one down to the bottom. So number 2, I'm going to move to the bottom. And the pi, I'm going to move to the bottom. And what do you know? I've got r left over. So I'm going to put all this together in a calculator, and I'm going to round to the nearest 10th. So I got 360 times 110 equals, divided by 306 equals, divided by 2 equals, divided by pi equals, I get 20.6. Cool. And now let's see if that makes sense. If this is 20, does this look like 22, 4, 6, 8, 10? Yeah, about 110 of those? I think that sounds about right. Awesome. 2 more questions. So it says select all the true statements relating to circles. The arc length of a circle, so that's this part, right? The arc length of a circle is the region bound by 2 radii. This is a radius and that's a radius, so yes. And the intercepted arc. But it says the region bounded. That's sounding like my sector. They're making it sound like they want to highlight this. This is the region bounded by that. So they're describing a sector. All right, here it says a sector is a fraction. No. An arc length is not the whole circumference, but a part of the circumference. So this one's right. This is an arc length. So I see what they did. They swapped these. Okay, the next one says, I'm still going to say no. The measure of an arc is equal to the measure of its corresponding central angle. Yeah, so we could call this 90 degrees, and we could call this 90 degrees. I'm going to say yes. A circle is the set of all points in a plane that are a given distance, the radii from the center. I think that sounds pretty good as far as the definition of a circle. A segment of a circle is the part of the circle. Okay, so we would agree with that. A segment of a circle. This is our segment of a circle. is the part of a circle bounded by an arc. Okay, so it's definitely bounded by this arc. And the segment joining its endpoint. Yeah, these are its endpoint. The arcs, yep. So I like that. Now you could Google these as well and notice you would have been able to find these answers for 30. All right, let's look at 31. An arc has a central angle of 2/5 pi radians. So let's think about this. We said in a radian, all the way around is 2 pi. So half the way around is just 1 pi. So a quarter of the way around is pi over 4. Or excuse me, pi over 2, duh. All right, so they're saying if this is 1 pi, they want to do this 2/5. So I'm going to cut this in 5 equal pieces. 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. Sweet. Okay, now this is not necessary for the drawing, but again, I like drawing things accurate because it helps me to decide if my answer makes sense. So this is saying this angle here, this central angle is 2/5 pi radians. I like that. The arc has a central angle and a length of 6 pi. So this is our S, and this is 6 pi. So we know our formula, S is equal to the angle theta, this is our theta, times R for radius. What is the circumference of the circle? So we're not quite there. We have S is 6 pi. So S is 6 pi. Our angle is 2/5 pi. And we need to solve for R. Once we solve for R, we can find our circumference. So what is our circumference? Well, our circumference is 2 pi r. So once we know what that is, we can plug it in. So we see an equation here, and I'm going to use the Lynch swap, where this number I can move up here. So I'm going to rewrite the problem and then move stuff where I want it. All right, so I said I'm going to move the 5 up here. So there it is. I'm going to move the 2 down here. So move it down, right? I'm going to move the pi down there. So I'm going to take this pi, move it down there. All right, now I have r by itself. That's what I wanted. Now let's look at what we've got here on the left. I have 5 times 6, so that's 30. And in the denominator, I have 2 pi. Interesting. So I can divide pi by itself. 30 divided by 2 is 15. So our radius is 15. So what would our circumference be? 2 times pi times 15 would be 30 pi. What do you know? There's our answer, guys. Nice job. Hope you have a happy Easter. Take care.